Hello everyone, welcome to my YouTube channel Big Data Hands-on Training, and this is Jay Prakash, and today we are going to see about Apache Spark, basics about resilient distributed datasets. And I'm using the Spark version 1.6.0, and I'm going to use my Hortonworks VM. I do have some issues with my Cloudera VM, so that I decided to use my Hortonworks VM. And the Hortonworks version Apache Spark is much more stable than your Cloudera. That's what I seen so far, so that I decided to use the Hortonworks. And you don't have a much better rich API support as like your Cloudera, but I can use my PuTTY to connect to the VM server. So this is the server name, so I'm just using my PuTTY to connect to it. And let me quit. Okay, let me quit. I think it's exit. So I'm clearing it, and I am invoking my Spark shell. So this is the command to log into your Apache Spark, and the Spark shell, it will invoke your Scala API, and the py Spark will invoke your Python API version. So I'm invoking my currently I'm invoking my Scala version of Spark. So we can use the documentation for Scala. I just click on Scala and I'm just using it. So let's use the documentation, and let's navigate with the help of the documentation. So what is an RDD? RDD, it is the expansion. It denotes resilient distributed dataset, which is a fault tolerant collection of elements that can be operated on in parallel. So let's see how to create an RDD. So RDD can be created by either parallelizing an existing collection or referencing an existing dataset in an external storage system such as HDFS or even your local file system. So if you could have observed a difference, you cannot by using your Apache Pig script, you cannot execute or import your file from your local file system. You have to move it to your HDFS and then you have to do an import. But in Apache Spark, this is possible. We can execute a file from your we can access your file from your local file system, and you can parallelize it. So let's go and see how to parallelize an existing collection. An existing collection. So ac.parallelize is the method that is used for parallelizing an existing collection in your driver program. So SC stands for Spark Context, and let's do the same. So go to my PuTTY. So let me do val. So it's value, and this is actually a Scala syntax. So val is equal to array 1 2 3 4 5. So we have defined an array. The array is defined. So b is equal to sc dot parallelize a. There is only parallel rise. Okay. Oops, again I made a mistake. It should be val. Just missed. We have to use a val over there. So this time I'm right. So this is how we can create an RDD. So a resilient distributed data set, you can understand that it is a distributed collection of data sets that are being that can operate in parallel on your memory. So that's what your RDD is. So we have created an RDD by invoking an existing collection using the sc.parallelize method. So after this RDD is created, you can use any actions to do further processing on your RDD. So we have created an array of 1 2 3 4 5. So let's see how to add all these elements in an array and display. So they have given an example also. So this is the method. So reduce is the method, and reduce a comma b is equal to a plus b. So it is going to add up all the elements in an array. So what are we going to do is b dot reduce a comma b a plus b. Okay. There is a bracket needed for this. It's not mentioned. B equal to a plus b. Yep, so it has executed a job, and it created the result. And also there is one more thing they have mentioned in the documentation, that we can create the number of partition by adding one more argument in this se.parallelize data. So you can give how many number of partitions that can be created when you are doing a parallelize. By default, if you don't give any partition, it will create it will automatically create it based on your cluster, but you can always override it by giving how many clusters you need when parallelizing. So you can give it like se.parallelize data comma 10. So we have done how to invoke an existing collection and create an RDD. So let's see how to use an external data set and create an RDD. So we need an external data set now. So I'm logging into my another terminal, and I'm just opening my text editor. So I'm just typing randomly some data. So I want to find the total number of the entire length of my text file. So I'm keep on typing. This is a test file to test for the length of my entire file. So I'm saving it. So this is the path root Prakash Spark, and I'm copying it, and it is in my local file, not on HDFS. So we are going to process a file that is present in local. So that is the beauty of Spark. So let's do like val test file equal to se.text file. By invoking this method se.text file, we can parallelize and any kind of file. So it is going to create an RDD, and if you are invoking from local, so we need to mention it like file : / then give the path test.text and close it. So an RDD will be created. So it has created an RDD. So it is a string RDD. So we are going to find the length of the entire length of this particular file. So how many number of records are there? So they have given the syntax also. So they have given, we can import from either local or HDFS, and various way of invoking the files. All this information have been given. So So this is a syntax. So the file name dot map, so there is a map function and a reduce function. Map function will get the length, so we are getting the length of the entire file, I mean for each record. So this map function, it actually gets a key value pairs. So the input file that has multiple records, so each record will be the key. So for each key, each record, length will be calculated, and further it is being aggregated. So the record length of each record is aggregated and being processed by the reduce function. So that's how we need to understand the syntax. So what we need to do is, we have invoked it. So test file dot map is equal to len of s dot length dot reduce e comma b a plus b. So this is the map function. Our file name is a. Yep, this is our file name, test file. So map function, we are finding the length of each record by using the key value pair. So key is the record, key is the row number and value is the length, entire text, and we are finding the length of each record, and we are aggregating it by using the reduce function. Oops, there is a small error. So test.map is equal to s.length. Okay, I think yes. So this is the result, and 59 is being the entire record length. So we can go ahead and test it too, just to make sure it is 59. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32 33 34 35 36 37 38 39 40 41 42 43 44 45 46 47 48 49 50 51 52 53 54 55 56 57 58, and maybe some spaces or something. So it is Greek. It will give the exact result. So it is giving the length, and we just seen in this video about how to what is an RDD and what is a parallelized collection, and how to create a parallelized collection, that is your RDD, by invoking an existing collection and also using external data set. So another beauty of Spark is we can invoke an existing file from your local machine, and it is not necessary to be in HDFS. So with this said, and we can see further on this particular documentation in my next video. And this is it for this video. So if you like my video, please click like, share it to your friends, and most importantly, subscribe. Thank you so much.